Okay, so this video is going to be on angles of elevation. When we're talking about angles of elevation, it's when we're standing somewhere and we're looking up. So this person's standing, his normal line of sight is straight ahead. It's a horizontal line. To look to the top, he's got to look up. So the angle of elevation is up. The line of sight is going to be the hypotenuse of the right triangle, which is what's drawn here. So we're still going to use, because this is right triangle, we're going to use one of our trig functions, sine, cosine, or tangent, to solve for whatever the missing value is. So an angle of elevation, when looking up to an object, the angle of elevation is formed by the observer's line of sight and the horizontal line. So the angle goes from the horizontal line to the line of sight. So let's look at a couple of examples, and we need to read these examples and be able to draw the triangle. So this says that Casey sights the top of an 80-foot tall lighthouse at an angle of elevation of 58 degrees. If Casey is 6 feet tall, how far is he standing from the base of the lighthouse? So I need, and luckily this appears to be the same picture that's drawn here. So I'm going to draw, to the best of my ability, Casey. Good looking Casey, isn't it? Is looking at an 84-foot tall lighthouse. So my lighthouse is 84 feet tall. And Casey is 6 feet tall. And it says that he's looking to the top of the lighthouse. And I want to know how far away from the lighthouse is he. So I want to know this distance. The angle of elevation is 58 degrees. So based on this triangle, I'm going to label my triangle with opposite and adjacent. Which trig function deals with the opposite and the adjacent? Now remember, we're going to focus on the trig functions of the sine of theta, the cosine of theta, and the tangent of theta. Remember, the sine of theta is opposite over hypotenuse. The cosine of theta is adjacent over hypotenuse. And the tangent of theta is opposite over adjacent. Now here's what we have to remember about our triangle, is that if Casey is 6 feet tall, it means that he is 6 feet, that his eyes are 6 feet off the ground. And that's kind of important for what we're doing, because the lighthouse itself is 84, but I'm going to have to subtract this 6 so that this distance is only 78, because again, he is 6 feet off the ground. So which trig function deals with opposite and adjacent? Well, that's tangent. So I'm going to set up my trig function as the tangent of 58 is equal to my opposite over my adjacent. Now, because I have a variable in my denominator, I'm going to have to multiply by x, because it's going to be a two-step problem. I'm going to have to multiply by x to get my variable out of my denominator. To get anything out of the denominator, we always have to multiply. So I get x times the tangent of 58 is equal to 78. Divide by the tangent of 58. So 78 divided by the tangent of 58, so x is equal to 48.7 feet. So Casey is 48.7 feet away from the lighthouse. Again, please make sure when you're doing this that your calculator is in degree mode. It does make a difference. If your calculator is in radian mode, it will give you an incorrect answer. So our next one says the angle of elevation from a kicker's foot on the football field to the top of the goalpost bars is 17 degrees. If he is standing 131 feet from the base of the goalpost, how tall is the goalpost? So, all of these are going to end up being a right triangle. I have a football player, or I have a kicker anyway. And it says that the angle of elevation from the kicker's foot to the top of the goalpost, so the angle of elevation is 17 degrees. He is standing 131 feet from the goalpost, and I want to know how tall is the goalpost. So based on this angle of 17 degrees, I want to label my triangle with opposite, adjacent, and hypotenuse. So x is the opposite, and 131 is the adjacent. What trig function deals with opposite and adjacent? Well, let's see. That would be tangent again. Tangent is opposite and adjacent. So the tangent of 17 is equal to the opposite over the adjacent. Now, because in this case, my variable is in the numerator, this is going to be a one-step equation. To get anything out of the denominator, I have to multiply by that number, or by whatever's in the denominator. So I'm going to multiply by 131. So 131 times the tangent of 17 means that my goalpost is 40.1 feet tall. So if Lee's mom is standing at the bottom of a playground, of the slide at a playground, waiting for Lee to slide down, the angle of elevation from the bottom of the slide is to the top is 46 degrees. The slide has a vertical height of 9 feet. What is the length of the slide? So we're at a slide on a playground. You know, the kind that used to burn us when we were little? Or did you just have the plastic ones? We had the metal ones that burned us. Am I dating myself? That's fine. Okay, so, and that's the mom standing at the bottom of the slide. This is Lee at the top of the slide, getting ready to slide down. So it says the angle of elevation from the bottom of the slide to the top is 46 degrees. It has a vertical height, so vertical is up and down, of 9 feet. And we want to know how long the slide is. So based on my 46 degrees, I'm going to label my triangle with opposite, adjacent, and hypotenuse. So my 9 feet is opposite, and my x is my hypotenuse. So what trig function deals with the opposite and the hypotenuse? Well, that's the sine. So the sine of 46 is equal to the opposite over the hypotenuse. So when I have a variable in the denominator, this is going to give me a two-step problem. So the first thing that I'm going to do is I'm going to multiply both sides by the denominator so I can get the variable out of my denominator. Multiplying both sides by x. So I have x times the sine of 46 is equal to 9. Divide by the sine of 46. And I get x is equal to 12.5 feet. So the slide is 12.5 feet long. The next problem. A dog is standing 5 feet from the base of a tree, looking up at a cat that has climbed 16 feet up the tree. What is the angle of elevation from the point the dog is standing on the ground to the cat? So we have a dog looking up at a cat. So I have a tree. And in my tree is a cat. Down here we have a dog. The dog is on the ground. And the dog is standing 5 feet from the base of the tree. and he's looking up at the cat. And I want to know, what is the angle of elevation if this cat has climbed 16 feet up the tree? So in this case, I don't know my angle, and I'm looking for the angle of elevation. I'm still going to set up my triangle with opposite, adjacent, and hypotenuse. So 16 is opposite, and 5 is adjacent. I'm still looking for the trig function that deals with opposite and adjacent. So that's going to be the tangent. So the tangent of x is equal to the opposite over the adjacent. Now, I need to figure out what x is, and I can't divide by x because tangent is an operation, and I cannot take away that operation. I have to figure out the opposite, meaning the opposite of, or the inverse operation. The opposite of addition is subtraction. The opposite of multiplication is division. The opposite of squaring is square rooting. So what's going to make this the opposite? So I'm going to do the inverse of the tangent. When I do the inverse, it switches these two components. So I'm going to find the inverse tangent of 16 over 5. In your calculator, that's usually the second tangent. So the inverse tangent of 16 over 5, the inverse tangent is denoted by this -1 here. So the tangent to the -1 is the same as saying the inverse tangent. When I put this in my calculator, again, make sure your calculator is in degree mode, I get x is equal to 72.6 degrees. So that's all I have right now for angle of elevation. Good luck.